And I'm pleased to introduce to you Charlie Xu, John Lewis, and Venkat Surapaneni later on to have a conversation. And we're learning about integrating MongoDB Atlas with your internal developer platform. Please give it up for them. Thank you.
That's it. All right, welcome everybody. As Alexa already said, we are from MongoDB, both of ourselves here. Charlie is a senior product manager on our Atlas team. I'm a product marketing manager here at our team. Oh, my mic's not on. I'm good? All right, thank you. All right. Sorry, so Charlie and I are both at MongoDB on a really unique and interesting team that we've been working with over the last couple of years around working with some of MongoDB's largest customers with tens of thousands of employees and developers, learning how to run MongoDB Atlas and MongoDB in general at just massive scale. And the things that you need to do to not just deploy really large applications, but also handle all the kind of the behind the scenes magic, the organizational challenges, the automation and operational challenges to make that possible with tens of thousands of developers. And at the beating heart of that is integrating MongoDB Atlas with some sort of internal developer platform. And that's going to be the heart of our conversation today. So I'm going to give a little bit of a preamble, a little bit of a teaser as to why this is actually important. There's a lot of hype around building new things, but sometimes the kind of the forgotten story, the forgotten heroes are actually managing these things and running the operations behind the scenes. So we're going to talk a little bit about cloud landing zones, MongoDB Atlas landing zones, and how to fold those into your internal developer platform, and why building one matters, how you can drive kind of consistency with your deployments, operational efficiency, developer speed and agility, kind of some key outcomes for actually building these things. And Charlie is going to walk us through some very practical demos on how to actually get started with this, kind of start the art of the possible and start beginning some of these best practices and implementations to bring this into your enterprise. So let's kind of set the stage as to why we are talking about this. The shift left mentality is not a new concept. It's been around for several years, really coined kind of with the boom of cloud many years ago. Feels like a very long time at this point. And the promise when cloud really started coming to fruition was that it was easier for application teams to start owning more of their stuff. Whatever that stuff may be, operating those services, the management of those services, the security of those services. The promise was that developers can kind of spin up their own things, manage their own things, and take that load off to, just could be a little bit more autonomous, a little bit more self-serving. But there was a bit of a double-edged sword with that, and many enterprises have realized that promise, but there were also a lot of organizations, I'm sure many of you in the audience today, experiencing this cloud sprawl where there were anti-patterns that emerged from developers doing their own thing, a lot of operational challenges that emerged. And candidly, and why I put this up on the screen, is I think that this is only going to get harder. It's only going to become more important as this AI explosion starts to happen. There's just new technologies, new development cycles. There's more pressure to just build more things, autonomous things. This is exponentially more complex. So these problems aren't going away. But I think the opportunity for our teams, our operations leaders out in the audience, that opportunity is still here. And it's getting even more important, as this era really comes to fruition. So you don't have to raise your hands for this, because I know this is sometimes a little bit sensitive, but I will see it in your eyes, the horror that emerges. But these are some of the horror stories that we hear from some of the biggest enterprises in the world that run any technology at massive scale across, again, tens of thousands of developers. Developers running their own instances and maybe spinning up a huge cluster for testing, and then they never turn it off for a day or weeks or months, and then you never learn about it until you have an angry CFO, ringing you up or pinging you on Slack asking why there's this crazy cloud bill coming out of nowhere. Or you do an audit and you see on your landscape, you do this audit and you see that there is just misconfigurations and shadow tools everywhere, and nobody likes to see that, seeing those audit results. And I think just more closer to home, operations teams just being drowned in developer access tickets, Jira tickets, manual processes. And really it's those manual processes at the end of the day that we're trying to solve with internal developer platforms and folding Atlas into those. But we don't really choose to get to this kind of terrifying horror state. a great quote I heard from one of our customers who leads a large architecture review board kind of told me that all these like manual operations, these poor developer experiences, we don't do this on purpose. Nobody seeks out this complexity. This all kind of happens from one good decision at a time, where one day it's a security process, it's an automation checkpoint, it's a review board, it's a Jira ticket here, a runbook there, and each one is solving a very important operational or security consideration at the time. But then what happens is over years, or maybe even decades, you take a step back and then you realize that a developer experience that we are kind of the stewards of managing is maybe not the best one. And there's this really just complex manual process behind the scenes, dozens of various operations and security and networking type teams who are involved in this important provisioning process. But then developers at the end of the day, it might take them weeks, if not months, to get into some sort of technology. Maybe it's MongoDB Atlas, maybe it's something else. And that is just that's a non-starter for how fast software development is getting and how important all of us are in running our businesses. So this is really where we are trying to find solutions with these teams. Cloud landing zones and internal developer platforms are the solution for this, and that's the playground that we get to play in. So again, why does this matter? I hope I'm really just stressing this super hard because I want to get everybody excited for the day and make sure that we're talking about more than just developers and development. We're talking about operations because again, I think cloud operations teams have an increasingly important role as this AI explosion really starts to come to life. The table stakes of ensuring the security, the availability, the performance of your cloud infrastructure is not going to go away. That's table stakes. That job is super important. It will always be important. But I think what's really interesting talking to some of these massive enterprises is that the remit of operations teams is getting larger. And I think that's super exciting. Like DevOps and platform engineering is an obvious one. But I'm seeing more and more architecture and cloud leaders asking about developer enablement, becoming coaches and trainers to the developers that are using their software. They're not just giving them things, they're also teaching them how to use them and use them correctly. They're also the leaders in newer or more important domains of operations, emerging domains of operations like financial operations and AI operations. They're not just kind of coming in and solving this problem multiple years in the future. They're building a landing zone, they're folding these operations into their foundational posture, which is, again, making sure that as this AI explosion happens, operations is not kind of a follow-on thought or something that is going to be thought about later on. So I'll kind of leave my preamble to set the stage really for Charlie to start talking about the meat of how to build these things by kind of just sharing what we believe our mission is, or the mission that we see with cloud operations teams these days. There's really a spectrum that we see between speed and control, and there's that spectrum. Everybody's going to fall on a different kind of piece of that spectrum here, but this is what a landing zone and an internal developer platform lets you really realize. On the one hand, you might be really interested in speed, making sure that developers can build as fast as possible with as little friction as possible. Maybe that means self-service access into something like MongoDB Atlas. Standardized workflows, guidance, runbooks, all of these things are designed to help developers be autonomous within some level of control and guardrails. If that sounds terrifying, many organizations definitely lean on the other side of control. Things like enforcing those security and compliance requirements that are just so important and cannot be forgotten. Making sure that infrastructure is right-sized. All the teams that matter, like operations, finance, procurement, have visibility into what's going on with a very large fleet. So I think really the point of this session, the point of landing zones and internal developer platforms is understanding what this spectrum is. This is our mission, and how do we actually make this real in the enterprise instead of just theory. So with that, Charlie, I'm going to pass it over to you and have you double click into what a landing zone actually is and how you should get started building one in your organization.
Yeah, absolutely. Couldn't have said it better myself, John. So a natural question arises, how do we balance speed and control in the enterprise? And our answer is using Atlas landing zones. Landing zones are a framework that allows us to define pre-approved Atlas environments for developers upon request. And these become the default starting points for new infrastructure that's provisioned. So said in a simple way, it's a template. Now, what can this template comprise? Now, we as platform engineering teams care about security, governance, and compliance of all of our cloud infrastructure. So templates give us the ability to predefine many layers of parameters for the cloud infrastructure along areas such as sizing, networking, security, and access. but still gives developers the ability to configure the parameters that most impact their application's performance. Now, let's talk through one example configuration template, and let's say that it's focused on a specific use case, a database with restricted data. So when a new MongoDB cluster is required that has data that we as an organization have flagged as restricted, we as a platform engineering team might say all clusters of this type need things like Atlas authentication via SSO in the corporate directory. It might require a replica set and allow the customer or the application team to manage the keys. But we also might say there are a couple elements of configuration that this development team can and should be able to configure. They should be able to configure a t-shirt instance size for the cluster tier, and we'd map that to an Atlas M50. And they might also be able to select AWS as the provider and say that the region that the cluster should be in is Zurich, and they might be able to choose from a very small number of permitted options for this template. So if the landing zone gives us the ability to define these templates, the developer platform is how we make these templates available to developers. So we'll talk through a couple different layers of the stack here and then go into the demo. In my experience, these developer platforms have many different shapes and sizes, but they always contain a couple common layers of the stack. The first is a developer control plane. So this developer control plane uses a developer portal to give developers the ability to define their infrastructure as code. Using an IDE, developers make changes to this infra as code and use something like GitHub to version control it. Now, when a change is picked up in GitHub, a CI pipeline will pass this configuration change to, let's say, a Docker instance that is running an instance of Argo CD as a CD pipeline. And this is what allows the changes in the code definition of infrastructure to be passed to the resource plane. Now, what cannot be forgotten is the concept of observability with a tool like Datadog, and secrets and identity management using something like HashiCorp Vault. And these layers together allow us to provide infrastructure to developers in a seamless way while still providing speed and a balance of control by giving us as the platform team the ability to enforce standards across all of our cloud infrastructure. Now, going into our demo a little bit, we're going to focus a little bit less on observability and security, obviously important, but focus less here. And we'll demo a little bit about how infrastructure can be defined as code, changes picked up, and then passed to the resource plane. So to structure this a little bit, well, I guess before we move into that, what I wanted to first share a thought on is why build all of this? Why invest in building a developer platform? And it's really to enable what's on the right there, reducing developers' cognitive loads so that they can move faster and speed them up, but still maintaining and protecting our organization's security posture and providing visibility for operations teams and finance. And we do this all by streamlining our operations via automation, via this developer platform. So the structure of our demo is going to comprise a couple different areas. We'll do a little bit of an overview of the platform team developer workflows, talk a little bit about our user personas. We'll walk through configuration of an example developer platform. We'll walk through the workflow of how a development team can use this platform to automatically create infrastructure, and then finally make a config change after that day 0, day 1 activity. How do we change and manage the configuration of this infrastructure over time? So our two main personas here, first the AppDev users, we'll call them the development team at the top left there, and the platform engineering team. They're using the developer platform Backstage.io, which creates a GitHub repo for the developers, maintains the code and configuration changes, and passes these to Terraform to have these changes reviewed and applied. So focusing first a little bit on the platform engineering team. What I as a platform engineering team care most about is making different layers of cloud infrastructure available to my developer base. I as a team might provide or manage dozens or even hundreds of different layers of the stack. And Backstage.io as an example developer platform is really useful to me because it provides a single place for all the developers to go to in order to provision, discover, and manage infrastructure. And I'm going to configure this Backstage instance to create a GitHub repo on behalf of developers. that contain their elements of configuration, but also standards that I want applied to every single cluster or piece of infrastructure across the estate, and then enable them to use a GitHub pull request flow in order to manage their infrastructure. So let's go look at a YAML file here that could be passed into Backstage. So a couple different important components here. The first is the types of parameters that we want to expose to the development team. You can see in the YAML file here that region is something that we as a platform engineering team might say developers can configure. And there's a subset of regions that we allow them to provision. Maybe we want all of our data to be in the continental US, so we expose US East 1 and US West 1 as two regions that are accessible to our developers to use when they use Atlas. The second is instance size. We might have guardrails on the types of instances that developers should be able to provision. And in that example there, I had chosen M10, M20, and M30 as the three that are allowed, but we know that Atlas supports many different types. And then finally, setting up this GitHub repo involves creating a number of different automation steps, an important one being copying GitHub actions into the repo, creating the repo, and also pushing the skeleton Terraform templates to this repo. So we're enabling a lot on behalf of developers through this pre-configuration and automation steps. And when I go into the Backstage portal and ingest this YAML file, what this means is I, as a platform team, have given developers the ability to provision components. And when we go ahead and click the Create button there, they're able to select the Atlas production Terraform template, which is the example we were looking at on the right. They can choose that one and then start the development team workflow that we'll cover next. So the key takeaway here is I, as a platform engineering team, have determined a number of sensible defaults, but also given the AppDev team the ability to configure certain elements of configuration. So moving on to the application development team, I, as a developer on a feature building team, really care about building my application and want easy and simple access to layers of infrastructure that enable me to do this. But I know that perhaps at my company there might be, again, dozens or hundreds of pieces of infrastructure that are approved, and I don't know the nuances of all of them. And I want to make sure that any infrastructure that I provision still conforms to the platform engineering team's security, governance, and compliance requirements, and just want to configure the portions that are most useful to me. So Backstage is useful to me as a developer because it gives me all of that. It gives me that discoverability and the ability to tune and configure those different parameters there. And it also sets up the pull request so that I can ask John and my engineering team to approve any changes that I'm proposing as part of this. So when I go to Backstage and want to provision a component that represents a layer of my stack again, I will go ahead and click that Create button that creates components that essentially represent layers of the stack or entire applications. Similar to the prior video, I'll go ahead and click the production Terraform template because this is the one that my team has assessed as most relevant to our needs, and fill out the pieces of configuration that are important to my application. Let's say that I know that most of the users of my new feature in maybe let's say a prototyping phase are going to be in the East Coast, so we're going to choose US East 1, and we're also going to choose an M10 cluster tier because this is the prototype. So I fill in a couple pieces of metadata, and the automation that my platform engineering team has defined for me runs. And you can see a couple different important steps in there, some being like creating that repo like we saw in the YAML definition, bringing in the Terraform skeleton and opening a pull request for this cluster creation. I can review the logs of this automation and then go to my feature repo that is owned by my wonderful solutions architect, go to the landing zone demo repo and see the repo that has been created for me. And this is done live seamlessly by Backstage because of the automation steps that have been defined by my platform engineering team. There's some content in here reflecting the GitHub workflows, and crucially, a pull request has been opened for the creation of my new cluster. So when I go into the pull request, you can see it start to show some elements of Terraform that you're probably familiar with. It's validated the syntax of my Terraform scripts. It has initialized the Terraform project. It has run a plan, and it is showing that the configuration options that I as a dev team have chosen are in this plan, but also maybe like a dozen or more sensible defaults configured by the platform team are also injected into the plan for this new piece of infrastructure that I'm provisioning. And when I go ahead and merge that pull request after, say, John has reviewed it and approved, I go to the GitHub action and can see that it is now being applied. So I'm using the GitHub approval workflow that all of us are familiar with to manage my infrastructure as well, and using Terraform to enable the actual application of those code definitions of infrastructure to Atlas. So now, say some time down the line, John and I worked on a feature for a month, and it went really well. It was a prototype. We developed it in a hackathon, and we now want to start bringing more users onto this prototype. You can imagine like 1, 2, 3 months down the line that there are configuration changes that we might want to make to this infrastructure. So as a development team, what I want to do now is use the Backstage instance and the repo that was created to modify the configuration of the infrastructure that has been defined. So I'm, as an app team, going to open a pull request, change the configuration, have John approve it, and then have those changes applied. So if I go into my repo again, you can see the original cluster creation Terraform apply has run, and it has created the cluster in Atlas on my behalf. So if we click open Terraform apply, you can see that after some time the cluster was created. It takes a little bit to provision the compute. And once I'm happy with this, I can go into the code definition of my infrastructure, and you can see that this step created a Terraform folder that has definitions of, among other things, my Atlas cluster, which I'm going to change, but also database users, IP access lists, our Terraform provider, all syntax that you're probably familiar with. Crucially, it has the Terraform state that is maintained for all of my infrastructure in Atlas. And the file that I'm going to change in order to change the instance size is my TFvars. And this file will probably look familiar from a configuration perspective. It is the small set of configuration items that my platform team has said I can configure, and also provides me simple access to just the resources and syntax that is familiar to me from an application perspective. So I'll go ahead and say that I want this to be an M20 now. We don't want a little bit more storage space. We want a little bit more compute capacity. And we're going to create this as a new branch to start the review process. So I'm going to create this branch and create the pull request. And after a little bit, our GitHub action to run the Terraform plan and validate this syntax change, make sure I chose a valid cluster tier, for example, will run. And this is a good time for me as an engineer to add my peers, such as John, to review this pull request to make sure that the changes that I'm proposing as part of this match will be agreed to as a team in our spec. And when I open that show plan, you can see that it confirms I'm modifying that landing zone demo cluster, and crucially, only the instance tier is changing from an M10, M20, and all of the other defaults, all of my other configuration is remaining the same. And it's confirming that I want to change here, and then once John, for example, has approved this change, I can go ahead and merge that pull request after it's been reviewed by the rest of the engineering team. And scroll down, merge that pull request, and then it's going to run the same GitHub action to apply these changes to our infrastructure. So we've used that same GitHub approval workflow that we all know and love, and have modified our infrastructure as part of that. So bringing it all back, ask yourselves, why do we want to do this? Why is this balancing speed and control? It's really doing this by building platforms and processes that enable our organization's requirements to be built into automation and not be something that we all need to go through and review every single time a change is made. Landing zones are the framework that give us the ability to define these templates, and developer platforms are how we make it available to our developers to consume and become discoverable as part of all of the different layers of the stack that our development teams have access to. And one last thought that I'll share is we went through a built-out demo here using automation, GitHub, Backstage. You don't need to go the whole enchilada. You can start small. You can start with processes and scripts that run on a developer's laptop and start with lower environments and slowly scale these up, all with a focus of helping your management of infrastructure via automation mature. So with that, I'll hand it back over to John.
Yeah, and I think that last point about just the focus on increasing maturity, I think that's really the name of the game, 1% every day type improvements where you don't need to go out and build this massive internal developer platform. We've seen enterprises that have really sophisticated teams and really sophisticated platforms, but it takes time to get there. So something that we've been investing in at MongoDB is just a variety of resources and programs in addition to our products and our automation products and our operations products, trying to build more resources to help you get started with this. So one of the more interesting launches that I've had the privilege to work on over the last several years at Mongo has been the well-architected framework for Atlas and the Atlas Architecture Center, which went live a little bit earlier this year. And in this, it's an extension of our documentation, and it has a lot of very practical, hands-on overviews and components and best practices, Terraform scripts and automation scripts. There's a lot of good content in there to help you start understanding, if I want to increase my maturity with MongoDB Atlas specifically, what can I get started with? What can I do in security? What can I do in operational efficiency? And that's a resource that we're investing in all the time. There's a really robust version log on there. So if you're looking to start bringing some of these practices specifically to MongoDB Atlas into your organization, it's a fantastic starting point. And of course, if you do need help with this, we have a variety of programs and teams who can help you build this hands-on as well. We have a pretty robust methodology for figuring out how to design your processes, your frameworks, design your landing zone, and then start building it and running it with your developers in the real world. Whether that's actually building all this stuff or, again, just creating documentation, creating training programs, helping you spread the word and kind of put you into that position where you're not just, again, providing infrastructure to developers, but you're actually helping them be successful, whether it's with us or with other technologies. So with that, I know we've got a few more minutes left in our little session here before we bring on Venkat to talk about what they're doing at Avalara. So I'll pause here for some Q&A. Is there anybody who has any questions about kind of what we've been talking about here or getting started with building landing zones? In the meantime, I'll leave some QR codes for some of these resources that we have, some of our tooling and some of our learning paths. But yeah, are there any questions about getting started with this in your organization?
Thank you. All right, just trying to get my head around this framework, right? So in a scenario, if I have like hundreds of Mongo clusters, so will I end up having one repository per each cluster with this kind of a model?
It's definitely customizable based on your organization's requirements. We have seen customers where a DB team is responsible for maintaining all clusters have the definition for all of these be in one repository and have a process using pull request reviews to allow the application teams to open pull requests for these changes. In more dispersed organizations where the application teams own the infrastructure as well, you could have a world where each application has its own repo with its own cluster, or perhaps like one team would have a repo for all of its clusters. So using our API in Terraform, it's fully customizable.
Okay, so the Terraform is making use of your APIs to create the clusters, essentially.
That's right.
Okay, thank you.
Yeah, of course. Great question.
Do we have any other questions, or? All right. Well, in that case, then, Venkat's asking a question.
Thank you, John and Charlie. I just wanted to appreciate the way that the demo actually worked great. So the thing is, isn't it amazing that your entire infrastructure has been scripted out into a Terraform state files and then stored in your GitHub repository, and then using the internal developer platform tool to deploy all of those policies in a single click of a button. That imagine you have your clusters running in AWS and you just wanted to deploy them to GCP or move from Atlas Cloud to an on-prem cloud. Now you have all of your infrastructure scripted out as a policy, and you have a CI/CD pipeline to just deploy it. It's just a matter of changing few parameters and run it wherever you want it to. So that's an amazing scripted and platform way of deploying the things in an easy way.
Yep, 100%. I think you hit the nail on the head. Changing something like a provider, adding nodes, for example, is all a code change that will be executed by the Terraform provider and API.
And I think what's really important with this, we were kind of saying this at the beginning, is this is the tooling, and the tooling is what makes this real. It's what makes developers actually access these things. But building a landing zone and the well-architected framework and all that is really also a strategic kind of choice. It is the very first step is designing like what are those steps or those processes, those constraints, those limitations, and sometimes those are just found in random documentations or wikis or Jira processes or whatever it is. But the idea, to your point, over time is codifying that into these modules, into these automation scripts, putting it into the platform to make it part of the product that you manage instead of being a process that's kind of managing you.
Right, absolutely.
Awesome. Well, with that, if you do have any additional questions, Charlie and I will be floating around after the session we can always answer your questions there. But for now, I guess I'll bring up Venkat from Avalara to talk a little bit more about their use with MongoDB.
Thank you, John.
All right. I think I'm supposed to put on that one. Perfect. All right. Well, welcome, Venkat. If you want to kind of kick us off here and tell us a little bit about yourself and Avalara to, again, set the stage for how you've been using MongoDB.
Sure. Thank you, John and Charlie, for inviting me here. And I'm very pleased to be with you all today, this morning. Before we dive in, I just wanted to tease the audience. Quick show of their hands. How many of you have heard of Avalara, or have you worked with Avalara tax compliance products in some integrations along the way? Does any of you know about Avalara or worked with Avalara in the past? All right, so there is one raised hand. So, and those of you who have seen our TV advertisement or know our brand, do you happen to remember our tagline? Like, what is the Avalara's tagline on the bottom? All right, so the tagline is very simple. So we make tax compliance less taxing and more relaxing. So if you look into the real advertisement, it's more relaxed. So that's what the story is all about today. So how we scaled that mission with MongoDB, serve millions of global transactions in real time across multi-cloud platforms. So that's what I'm going to talk about today. So Avalara is a cloud-native global tax compliance organization. So at core of our mission is to help our businesses enabling the tax compliance easily, efficiently, and accurately. So the businesses need not to worry about the changes of the complex tax rules or the deadlines of the tax returns filing. So it's makes the business's tax compliance life easy. So our vision is to be a part of every transaction in the world and helping our businesses of all sizes addressing the tax compliance needs. So what I do at Avalara, so I'm a principal architect at Avalara. So where I lead the large-scale data platform engineering and the AI architecture initiatives. So our shared platform services team is responsible for building scalable, resilient, and highly intelligent systems that Avalara's supporting the global tax compliance services, including some of the services like AvaTax and returns. So in core at Avalara, we build the principles of simplicity, ownership, and innovation, ensuring that we support all the Avalara's global tax compliance initiatives.
Awesome.
Back to you, John.
Thank you, Venkat. And I think before we kind of move on to your use case, I do have to say, as a marketer myself, I really do appreciate your company's tagline. I think building planet-scale systems like this is very, very hard. I think just right below that in terms of difficulty is naming things and coming up with really good marketing taglines. So I do have to say I really deeply appreciate that. So tell us a little bit more about what brought Avalara to MongoDB in the first place. What was that major project or major application that really made you say, we need MongoDB for this?
Yeah, sure, John. So so the problems that we were solved within our legacy technology systems is back in the days of in 2020, so we were running our largest global tax compliance system, transaction store, running on the SQL. The legacy SQL systems were limited our ability to go or expand into our planet scale. to hundreds of billions of transactions. So the OLTP workloads were failing to meet our P99 and P95 latency or SLA requirements. The tax domain and compliance industry itself has a very strict requirements on ultra low latency and a very massive data growth and high availability requirements. And then also like analytics and reporting systems are timing out on the legacy systems, having a customer delays. So all of that, we need a platform to, and also like our platform need to support geo-redundancy and resiliency across various clouds and regions. So we need to re-platform our Avatax into a modern, intelligent, global edge computing to support our real-time AI copilots and decision-making systems. So as part of that re-platforming architecture, we chose MongoDB Atlas as the foundation layer in our global architecture team as part of our Project Polaris and Project Active-Active due to this flexible MongoDB schema and then the high availability architecture and then supporting the multi-cloud geo-redundancy infrastructure. So that's how we chose MongoDB as our one of the foundational platform component in our data infrastructure stack.
Awesome, thank you, Venkat. And can you maybe double click a little bit more on what Project Polaris specifically was and kind of how you approached doing a project at that scale?
Sure, so as I explained, MongoDB Atlas was chosen as a foundational layer in the Project Polaris. So the Project Polaris, which we started around back in 2020, which was a modernization effort for the Avalara's monolithic data infrastructure, moving into a unified distributed platform using MongoDB Atlas and also other modern systems like Snowflake and Kafka and other systems to support our low latency and high availability based tax compliance and analytics systems. So that's the first project that we use MongoDB as a backend, and we successfully transitioned from our legacy systems into our MongoDB Atlas based systems at the middle or end of the 2022. That's awesome. About Project Polaris.
Yeah, and I recognize that was a very large migration project. So what was some of the benefits that kind of came out of that? I know you're already touching on them a little bit, but what were some of the business impacts or the customer impacts that your team has found by moving to MongoDB Atlas from your legacy SQL monolith?
Absolutely. So the business benefits or the impact has been substantial. So we created a unified real-time platform. MongoDB Atlas enabled us to consolidate the legacy systems into a modern operational data layer that supports the scalable ingestion, low latency based queries, and then flexible data modeling. And then we actually improved the global resiliency and availability by deploying into multiple regions and then failing over beyond a single region, and also increasing our durability beyond a single node. And then we also we also achieved a cost optimization as well, consolidating workloads into MongoDB, reduced our operational burden, and then costs associated with managing disparate data sources has improved a lot. And finally, the developer velocity. So now Atlas flexible schema and managed services allowed us to onboard the engineers faster, reduce the operational toil, and then the focus on the innovation. So those are the key benefits that we have realized after we migrating into an Atlas developer data cloud platform from the legacy SQL systems.
Awesome. So I know that was already one very large migration project, and you are currently looking at doing another very large project with this active-active kind of multi-cloud architecture you're looking to build out. Now I know you have a session on that later today, so don't want to spoil it too much. Anybody here who wants to join that, make sure you tune in later this afternoon for that. But do you want to give a little bit of a teaser on what that project is, and again, like why you're choosing MongoDB for that project?
Absolutely, John. So as I explained, Project Polaris was our the foundational uplift on our platform, on our storage platform, migrating from legacy SQL into a modernized data platform, distributed data platform, MongoDB. And as part of that, as I said, we migrated into a single central cloud located in AWS, where all the customer data is located over there, and now we are building, layering on top of the Project Polaris. If you double click on that, that is called as a Project Active. So while the Project Polaris laid the foundation of modernizing our data stack and enabling the AI-driven insight, the Project Active takes that transformation into the next level. The initiative is all about building true cloud resilience and global scale for our flagshipping product Avatax and expanding it into other Avalara systems. So, so the operational, at its core, Active enables simultaneous real-time operations across multiple cloud providers, across AWS, OCI and GCP, and soon Azure. So we can serve our global customers from the nearest Active sites with a minimal latency. As you all remember, the Dave was talking in the morning, so we meet the customers at the edge. And then also the Boris talking about one database, all environments. That's exactly what we're trying to do. So Active project is about serving our customers where they are located, bringing Avalara systems close to the customers where they are located by helping them to do the tax compliance at the edge. So we can serve the global customers from the nearest active site with active sites with minimal latency, hot failover, and no downtime. So, and also think about ransomware protection and cross-cloud disaster recovery, AI-ready vector search, and intelligent traffic patterns, like all working in real time. So this isn't just about an uptime, migrating from one cloud to other cloud. It's about delivering the intelligent tax compliance at the edge, wherever our customers do the business. So if you happen to, if you wanted to know more about this, so I'll be diving deep into the actual architecture, use case, and our journey into Active platform in our afternoon video recording session with the customer marketing team. Once it's not a live session, but it's a recorded session. Once it is available, you can listen to it later on.
Awesome, thank you so much. And I think something that I'm really interested in hearing about is how, when you look at projects of this scale, bringing MongoDB Atlas to critical workloads, international workloads, tons of developers, what's one tip that you would give to a technology team looking to maybe adopt MongoDB for the first time or do a very large project, a migration project on their own? What's that one tip that you would that you've learned that you would like others to
Right, that's
learn
a great question. So we were also listening about the application modernization platform, migration from legacy systems to a modern data systems. So this is all music to our ears, but the biggest piece of advice that I can give while migrating a largest migrations into the modern distributed database systems like MongoDB is to balance speed, performance, time, and cost governance. So large migrations, especially the cohort-based migrations, like you don't want to do a lift and shift of all of your customers from a legacy systems into a new system. You wanted to split your customers into cohorts, and you wanted to migrate each cohort them, and then understanding your business risk of each customer and migrate each one of them separately. So when you do the cohort by cohort migrations where the old systems and the new systems are running in parallel, so that can balloon your infrastructure costs. That is like, you would be paying a bubble cost for a short period of time. So if you're not careful with those, planning of those costs, so the cost will increase significantly. So my recommendation is be realistic about migrations, timelines, and then do a thorough testing with the human resources and the budget impact and the performance trade-offs. So build time for the evaluation cycles and rollbacks. So it's not just about a technical challenge, it's about the operational and financial one. So getting that right can make the difference between a smooth rollout and a runway project. So be careful about those migrations and prep for the large migrations ahead of time.
Awesome, thank you so much. Yeah, music to my ears hearing about, it's not just about doing the work, but building a framework and a process around balancing the trade-offs between kind of going fast and adding in some testing and breaking things down so you can fail back if you need to. So it's a very exciting sounding project. So that does leave us with our time here. So if you do have any questions for Venkat or ourselves after the session, definitely we're going to be hovering around after to, if you want to learn a little bit more about these projects, Project Polaris, Avalara, and what they're doing with this active architecture, or you want to learn a little bit more about internal developer platforms and how to get started with those, find Charlie, myself, and Venkat after the session, and we're more than happy to double click on you, on that with you. We'll also be at the product booth for MongoDB at the end, which we will double click a little bit more into this as well.
Yeah, so whoever have their raise hands, for the interest of time, so I would love to talk to him off the stage, because the next session is going to start here soon, so I would be happy to answer your questions.
Awesome.
Thank you.
Thank you so much.